Hi, in this video we will look at the common physical and chemical properties of the transition metals and compare them to the Group 1 alkali metals. Don't forget to check out part 2 of this video. The transition metals are found in the middle block of the periodic table. That is the block coloured red in the image shown. The transition metals are typical metals and have the properties that most people associate with a metal. For example, they are good conductors of heat and electricity. They are malleable, ductile, shiny, hard, and they have high melting and boiling points, except for the metal mercury, which is a liquid at room temperature, and 3 of them, iron, cobalt and nickel, are also magnetic metals. Compounds which contain metals from groups 1, 2 and 3 of the periodic table are white or colourless. For example, table salt or sodium chloride is a colourless white solid at room temperature. And when these compounds are dissolved in water, they will also form colourless solutions as shown. However, many transition metal compounds are coloured. The image shown contains some common transition metal compounds that are coloured and which you may have seen dotted around the lab at times. Many of the coloured transition metal compounds are found in gemstones and minerals and are responsible for giving them their characteristic colours. For example, the presence of iron in titanium gives sapphires their characteristic blue colour, while rubies are red due to the presence of chromium compounds. Many of these coloured transition metal compounds are used to glaze or colour pottery. For example, cobalt oxide gives a wonderful blue glaze, while copper oxide gives a bright, vivid green glaze, and iron oxide has been used for thousands of years to give pots an orange colour or glaze. In an earlier video, we looked at the physical properties of the Group 1 alkali metals, lithium, sodium, potassium, rubidium and cesium. So how do the physical properties such as density, melting point, hardness and strength of the transition metals compare with these alkali metals? Well, let's start off by looking at density. You may recall that lithium, sodium and potassium all react very violently with water and that they float on top of the water as they react. So this means that they're all less dense than the water. Now the density of water is 1 gram per cubic centimetre. So these 3 metals all have densities less than 1 gram per cubic centimetre. The densities of the other 2 metals, as you can see from the bar chart, are slightly higher than this. Now if you compare the densities of the transition metals with those of the alkali metals, then even a low density transition metal, such as titanium, with a density of 4.51 grams per cubic centimetre, is much more dense than any alkali metal. The densities of the transition metals are generally much higher than the alkali metals. For example, metals such as iron have a density of 7.86 grams per cubic centimetre, and mercury, with a density of 13.5 grams per cubic centimetre, are much more dense than any alkali metal. In fact, the density of mercury is almost double that of iron, and nails made of iron will actually float on top of liquid mercury. Transition metals such as gold are very dense, with a density of 19.3 grams per cubic centimetre, while osmium is the most dense metal with a density of 22.59 grams per cubic centimetre. A similar trend can be seen with the melting points of the alkali metals and the transition metals. Lithium, the first alkali metal, has the highest melting point of the alkali metals, but even still it's only 180 degrees Celsius. While the trend in the melting points for the rest of the alkali metals is that they become lower as you go down the group, with cesium metal close to the bottom of Group 1 melting at only 28 degrees Celsius. The melting points of the transition metals are by comparison much higher. For example, gold melts at 1064 degrees Celsius, silver 962 degrees Celsius, and iron at 1538 degrees Celsius. While tungsten, the metal used in light bulbs, has a melting point of 3422 degrees Celsius. Other than mercury, which is a liquid at room temperature, the melting points of the transition metals are very high in comparison to those of the alkali metals. The alkali metals are soft and easily cut with a knife. Lithium at the top of group 1 is the hardest alkali metal, but even still it is very easily cut with a knife. The transition metals, by contrast, are much harder and stronger than the alkali metals. Typical uses of some transition metals include: copper is used to make pipes, coins, and electrical wires, while metals such as gold, silver, platinum, and palladium are commonly used to make many types of jewellery. Silver and gold are also used to plate many items used, for example, in jewellery, photo frames, cutlery, plates, tea sets, and ornaments. Steel is an alloy of the transition metal iron, and some alloy steels also contain the transition metals chromium, vanadium, manganese, and nickel. Steel is an important construction and engineering material and can be used to make a wide variety of items such as tools, ships, bridges, cars, washing machines, screws, nails, and cutlery, but to name a few. The transition metals are much less reactive than the alkali metals. We can easily demonstrate this in their reactions with oxygen, water, and halogens such as chlorine. Now recall that the alkali metals are stored in jars containing paraffin or oil to keep water and oxygen from them. If an alkali metal is cut with a knife, the freshly exposed shiny metal will quickly tarnish due to reaction with oxygen in the air. And when heated on a burning spoon, the alkali metals all react violently. The transition metals, on the other hand, react only slowly or not at all with oxygen unless they are heated strongly. Copper metal, for example, when heated in a Bunsen flame, simply changes colour as it is oxidised to black copper oxide. No flame is seen in this reaction. Other transition metals, such as platinum and gold, simply do not react with oxygen at all. Now let us compare the reactions of the alkali metals and the transition metals with water. While the alkali metals all react violently with water to form metal hydroxides and release the flammable gas hydrogen, the transition metals, by contrast, react very slowly, but most do not react at all with water. For example, if a sample of a transition metal is placed in a beaker of water with an inverted boiling tube filled with water on top, then any reaction which takes place can be seen and any gas given off can be collected in the boiling tube. While, for example, the transition metal iron will react slowly with water and oxygen and corrode, most transition metals, if placed in the beaker, will appear totally unreactive with water. It is a similar story in the reactions of the alkali metals and the transition metals with the halogens. The alkali metals react violently with the halogens to form white, colourless ionic compounds. For example, if a piece of sodium is placed in a flask filled with dry chlorine gas and a drop of water added to start the reaction, then almost immediately a very violent and vigorous reaction takes place in the flask, which is quickly filled up with dense fumes of solid sodium chloride. If the sodium is replaced with iron wool this time, then the wool needs to be heated with a Bunsen burner before being lowered into the flask of chlorine gas. A glow will be seen as the reaction takes place and the flask is quickly filled with brown fumes of iron chloride. For more information and help on transition metals, don't forget to check out part 2 of this video and also to visit the website that accompanies these videos.